All right. Hey, everybody. Sorry for the late start. I had to wrap something up kind of on shorter notice since it's Friday. I wanted to get it in before people go home for the weekend. So um, just kind of came up on my plate kind of quick, and I just wanted to finish it before we started. Welcome, everybody. Hello. Hope everybody's having a good Friday. Happy Friday. So welcome to Study Hall. This is a place for you to bring in your questions, and if you want to discuss anything, any like kind of outside topics, maybe if you're in study or if you're in premium prep, I know sometimes we talk about topics kind of briefly, and sometimes it's kind of fun to be able to like dive into those. So feel free to bring in to the table whatever you want to discuss. I want to keep things constrained to topics on beginner and intermediate, maybe advanced-ish Python, um, so that we're oriented around sort of topics relevant to addressing the or getting people ready for the technical interview. Tovio will be streaming occasionally. They're actually going to be out of town this week. They'll be camping, or this next week, and they are going to have streams on more stats and probability related topics. So if you have those kinds of questions, that's the best place to bring them. Cool. And I do see we're starting off strong. We've got a question right out of the gate. Welcome everybody. Go ahead and say hi. Give me a little emoji or say hi or something in the Slack thread if you're in there, or if you're watching. It's just nice to see people there. So, all right, let me get into this here, and we'll start in with this question. Okay, and this just says having troubles with tuples, question 3, and we've got a link. Thank you for the link. That makes it nice and easy for me. Hey there. And somebody's also asking, is this the right place time to ask about lambda conversions? Oh, okay, yeah. Sorry, I just saw that. Yeah, that would be for Tovio, best for Tovio streams. Okay, declaring tuples. Let's go down to number 3 here. Okay. So we'll just pretend like we didn't see this solution that I had there before. I'm just going to paste this in my notes document. Is that okay? Okay. There we go. Okay. So let's talk about this problem here. Write a function called tophold info that takes 2 arguments. Okay, so let's do that. So I always like to do this thing like whenever something, as soon as something is obvious, no matter how small it seems, I like to just do it, right? So what I know to this point is that I have to write a function with this name. It's going to take 2 arguments. Let's see what those are called. First called list will be a list of values. The second called find. So let's do list and find. There we go. Then we'll do a test. I don't know what it's supposed to do yet, but I'm going to write a test. And that'll help me understand what it's supposed to do. Once I read through the problem statement all the way. And then let's just call these A and B. Or this is going to be a, I'll just call this my list, and B for find something. We'll just do this. Kind of lazy naming, but you know what? It's not a big deal. Okay. And I've got to set these all equal to something. So these are going to be equal to, do those for placeholders for now, and I'll come back to that. So the second called find is a list of value, or excuse me. The second called find is the value to find. Okay. So list will be a list of values. That should be easy to produce. So let's make a list of values. Let's just do numeric values. Cool. And then this should be some value to find, presumably in the list. The function should return a tuple containing the value that was supposed to be found. So that's find. Well, that's easy. So let's just write it to return a tuple. Return a tuple with the value that was supposed to be found, which is called find. And what's the next one? The number of times it was found, and a list of the indices where it was found. So the number of times that it was found is the count, right? So if I do list.count find, that should just do those two. So let's have, I've already got a couple ideas for tests here. So I'll just use the same list. So I notice 55 shows up in here twice. Let's just, I don't know, we'll do that. We'll just add it in there a couple more times. I've got some redundancy here. I'll just use these lists. So let's look for 55. We'll look for something that's in there. We want to look for something that's not in there. I don't think I've got a, oh, I do have a 99. I don't have an 11. So 11 is not in there. And then let's just look for something else. 44, I guess. Or let's look for something that only appears once. So I think 33 only appears once. Nope, that's twice. 88. Let's do 77. Okay, 77. I'm just gonna get, okay. So we'll do 77. Okay, so for each of these, I can make my life a little easier by writing out an expectation. Exp. I'll just call this exp, and I'll say we'll do this none for now. And I also got to get in the habit of just doing this right out of the gate because I'm doing this more and more. I'm going to say, oops, wrong shortcut key there. Okay. I'm going to call this res equals this. So res is short for result. And let's give these a bit of separation, each one of these. Just so it's kind of clear where each of my tests begins and ends. And then for the prints, I'm just going to say res, res equals exp. And then I'm going to print res as well, because I want to see what the result is. So for this one, so each exp is my expectation. So for this one, I'm going to say, I know, in fact, for all of these, I'm going to say I want to have a tuple. And the tuple looks like it's going to hold 3 elements, which is going to be the find, which is just going to be something. Oops, let me do this. That'll always be something. And then the number of times the count of times that it occurs. Okay, so for this one, I'm counting 55. So that looks like it occurs 4 times. And then we also want a list of the indices. So that's going to be index 0, 1, 2, 3, 4, 5, 6, 7, 10. 0, 0, 5, 7, 10. Okay, so 0, 5, 7, 10. Okay. And then for this one, 11 shows up 0 times, and let's just see if this has. See, I'm writing tests as I'm kind of working my way through the problem statement. So that way, like, I have these concrete references for different scenarios that might occur. And I always want to have sort of I always want to have a case that covers, like, well, what if it's not in there, or the sort of null case or a false case, right? So in this case, I have a question here. Do I return an empty list? Do I not return any list here? So I actually don't know. I'm going to assume it's going to be an empty list, but at this point, since I don't know that for sure, I'll just read through and see if it confirms that or tells me what to do. So this is telling me the second parameter. This function should return a tuple containing, and let's do this, containing the value that was supposed to be found, the number of times it was found, a list of the indices in which it was found. The values should be returned in the tuple in that order. Okay, good. So it doesn't tell me, so I have to just assume this. If you're not sure about something like this, you can just take a note, like, not sure you can say not sure if I need an empty list there. Or you could sometimes I'll do stuff like this where, I'll just comment out the other case that I think it could be, but, and then that way I know, well, it's one of these two. So in this case, I'll just leave that as a comment there, and that'll kind of help me remember, that this was a point that wasn't totally clear. And that'll help me debug it, right? Like if I submit it and it goes wrong, I can maybe come back and look at my tests and see if they were the way that Learn was expecting them. Okay, cool. But I'll just assume that we're going with the empty list for now. And then for this one, let's just do 77. Now 77 just occurs once, and it is located at 0, 1, 2, 3. So it's going to be a list with 3 in it. Cool. All right. So I've done those two, and now I think I want to do ID indices list. And with this, we'll just do for element in list if element equals find indices list dot append index. So I've encountered an interesting thing where I want to append the index, but notice I don't have access to the index. Well, that's fine. That's not a big deal. It's really easy to get access to the index. Anytime, sorry about that cursor jumping around there. Anytime I'm writing a loop and I think, oh, I need access to the indices of this list, or collection, whether it's a list or a string or a tuple or whatever it is. It's really easy to do that. You just do enumerate. We'll just enumerate, and that changes our for loop a little bit. We'll have to do IDX, and so that'll say IDX and element, and here we're using element, and here we're using IDX. So let's just run this, see what we get. Okay, cool. So I skipped this step this time, but usually what I'll do before I get into like solving the whole problem logic, I'll actually I'll just write my function head like this and then test my tests just to make sure that the tests are written correctly. You know, if I made some error and I did res equals res, this is going to say true. And true is what's telling me if the test is passing or not, right? So if I made a typo here, I want to know about it before I get into things. Now with a small question like this, it's not a big deal. It's pretty easy to catch if you got something wrong. But it's a good habit to get into if you're writing a test. You want to test the test first, and then yeah, and then go from there. Cool. So let's run that. And that's correct. Let's see what I submitted before. I won't be surprised if it was exactly the same. This appears to be exactly the same. Looks like I gave these different names. Called this list append, IDX, and yeah, that's exactly the same logic, but just slightly different parameter names, variable names, and things. And let's see what this one was. Oh yeah, here's a variation that I had. In this case, I'm making the tuple right away, right? And then this is actually holds the list accumulator, right? So I'm just saying tup and putting element to find list.count element to find right into tup. And then I'm starting an empty list and then appending into that list in the tuple. So tup sub 2, which is that list, dot append, tup sub 2 dot append IDX. But other than that, I mean, in this case, I just have it, the accumulator basically in a different spot, but it's the same thing. Cool. We've got another question here. Somebody's submitted some code, and if you can give me a link to this, this looks like it's from Learn. If you can just give me a link to wherever it's from, then that'll be great. I will pull in the code. It's hard for me to start working on something if I don't have a link for it, though. Okay. Okay. So this person's asking, wondering how I would structure the code to solve this problem, and if there's an approach that is best suited for it, perhaps one that we haven't fully learned yet, like a recursive function. One way I'm seeing now is just using a bunch of for loops, counters, or Boolean flags, which will get complicated very fast. Yes. Let's see about this. I might do like a, this is a weekly challenge. March 8th, write a function called largest sub sum. Okay. Let's just do this. I think I can just yeah, I can turn all these into tests really quick. So this should return bit is going to be our expectation. The function call is going to be our result. Oops, there we go. And then let's do print res equals exp, comma res. Okay. Write a function called largest subsum that finds. I gotta go check that copy. That finds the largest possible continuous subarray sum in the given list. Ooh, I did this one a long time ago. I don't remember how I solved it. I'm gonna have to rediscover how I solved this. This is gonna take in a list, and it's gonna return the largest subsum that finds the largest possible continuous subarray sum in the list. Interesting. Okay, so oh, I'm thinking I think we could just use a nested loop for this. For I in list, for J in list. Yeah. And I think I actually want to do range len because I think what I want is the indices. Yeah, that's what I want. I want the indices. We'll do range len. So if you don't know, range len is going to give me the range. Range takes in a number and gives me back an iterable. So it takes in an integer and gives me back an iterable object, related to that integer or the size of that integer. And then len sort of does the opposite. So this is basically a way of iterating through the indices only. So notice I have results here. What I'm going to do, I'm just going to say if j is greater than I, then I'm going to results dot append the sum of the slice from I, starting at I up to and including j. I'm wondering, I think maybe I want to do greater than or equal to. Slicing logic, I always have to think through it like every time. So I want to know, so right now I'm thinking, well, what if they're the same? Like what if the largest continuous sum is, like, what if we have something like this? Like we've got 10 and then this is negative and this is negative and this is negative and this is negative. So the expectation here I think would be 10. That makes sense to me. So I do want to be able to check a range that evaluates to a single number. So let me just, I'm going to try slicing that range. Oops. In here, I'm going to say list equals this. And then I'm going to say list I equals 1 and j equals 1. And then I'll say list sub I colon j. We'll try that. I think I need to do j plus 1 there. Yep, I do. I need to do j plus 1. There we go. Okay, so it's list sub I, list sub I to j plus 1. Okay, that's what it is. So we'll do that. And then I think from here, it's just we're going to return the max. Oh, no, it's not the, so we want to, oh, that's interesting. That's interesting. So let's actually append, we're going to append a tuple. We'll do this. We'll append a tuple. The first element will be the sum, and the second element will be, yeah. This is called sub. I'm going to call this sub like this, and we'll say if I is greater than j, we'll say sub is equal to list sub I to j plus 1, and then we'll append a tuple containing the sum of sub and sub. So let's try that. Let's try that out. And then I think what I want to do here is find the max. Max arg is an empty sequence. So max can't have an empty sequence as an argument, and there is a place where we're giving it an empty sequence, which is down here. So I'm just gonna handle an edge case, and I'm just gonna say if list equals empty list like this. You could do if not list. I usually do it the other way, but you could do it this way. Then we're gonna return empty list. Let's try that again. Okay, cool. So we're not quite, notice our last test is the edge case, so that's passing, that's good. Our other cases aren't passing yet, but it looks like, yeah, if I look at this, 4 minus 1 is 3, plus 2 is 5, plus 1 is 6, so that's 6. 14, 5, 2, 7, 5, 2, 7, 10, 10, good. And then this should be 1, 10, negative 4, 5, negative 6, 7. And I've got 1, 10, negative 4, 5, negative 6, and 7. So I have isolated all the correct places. So what I can do is this max is going to give me back that tuple. And I'm going to index into that tuple at index 1 where my lists live, and we'll see all trues. That passes. So this one just needs a nested loop. And I know the question was framed, the person who asked this question was, had framed it around like, what's my impression of the best way to solve this problem, if we could do a recursive solution. Oh, and of course this does not even work. Okay. Oh. Well, would you look at that? So this is kind of interesting because the examples, oh, this should return part. So we don't actually want that. So I wrote sort of the wrong function here. Dang, because it's actually really cool. The function that I wrote is actually really cool. We'll write it the right way now. So we actually did want to do the just the sum. I don't need to do the thing with the tuple. and I'll just do max like this, and shoot. So that was supposed to be 6, 14, 13, 0. So let me do this. Max equals. Oh, I got an extra space in there somehow. X equals, and that was supposed to be 6. Let's do this. Oops. 6, 14, 13. Oops, that's going to be 10. This next one's going to be 13. And this next one's going to be 0. We'll do this. Okay, so that works. Good. Let's try that out instead. Okay, cool. And it looks like this is taking the same approach that I did. List equals empty list if the length of the array. Oh, this is the edge case. I just laid that out differently. There's a convention around this that I follow to put edge cases up front, at the very top of your function. Sometimes you kind of can't get away from that. Sometimes you need to, there's something that you definitely think of as an edge case, and you need to run some process and discover the edge case later in the code or at the end of the code or somewhere else. But if you can check and handle an edge case, the idea is to do it as soon as possible. And in I'd say a good majority of cases, you can just do it right away. And a lot of edge cases are around like, did we get the right type, or is the value correct, or whatever. So they're handled first. And then what I like to do is always keep my accumulator target right above the loop, right immediately above the loop that I'm accumulating into it. So this is what I like to do. And I suppose since I'm only using, since I'm only using this in one place, I can just append the sum directly. I don't need that other variable. So that's an improvement I could make. Okay. And now I'll submit that. So you can always go back and clean up your code. That's the thing. Yeah, okay, cool. So I'm just catching up. I noticed there was some activity that I kind of missed while I was in the heat of solving this. I kind of had fun with this one, so I kind of got into it. Just want to address some of these points. Somebody's saying, the original poster is saying, right now I and J represent the indices, and I just want to clarify why that's the case. So if I were thinking about this, the way this question was framed, like should I use recursion or another advanced technique or something, if I were thinking about like how do I go through and like construct something that gives me like ranges of elements by elements, then I think I would start thinking about it like maybe needing recursion. But if I just think about it like if I just get the indices of the list, if I can get a lower index and an upper index, I can loop through that in a way that gives me a range, so I can slice every possible sublist, every possible sub slice. if I have an upper and a lower bound. And that's all I need is this. I will use I for the lower and J for the upper. So nested loops, this particular kind of nested loop where where you're iterating through the same range and using the element or the identifier as an index. Um, this is, I think about this as somewhat of a form. I can't say I use it that much because I don't encounter that many problems where it's like, what's every possible sublist? But this is the answer to that question. To me, when I think about the what's every possible sublist, um, you can do you can do a nested loop, and um, just the nature of that, like we can think about, they'll both start at 0, and then J will continue 0, 1, 2, 3, 4, 5, 6, 7, 8 until the end, and then I will advance to 1, and J will start at 0 again, and 0, 1, 2, 3, 4, 5, 6, 7, 8, and then I advances to 2, and 0, 1, 2, 3, 4, 5, 6, 7, 8 until I advances all the way to the end. And that's going to give you the ability to slice every possible sublist. And then this if is just, it's going to save me from doing negative slices. Not that that's really going to be that bad, but I'm just going to end up with a bunch of empty lists in there that aren't going to do me any good. And I'm going to be doing this append and the sum and the slice, which are all, they're not all that heavy, but this just increases, this just makes sure I'm doing the work when it's actually going to mean something. So I think there's other ways to optimize this, but this is just a little optimization. And then obviously just returning the max of that. Since I'm appending the sum of the sublist, I'm just returning the max of that. Cool. All right. All right. That was a fun one. Hoping I'm not missing anybody. Looks like that's what we got for right now. All right. I want to give you all an opportunity, if you've got any other questions, go ahead and put them in. I'll just put like a minute on the clock, just wait and see if anybody wants to get a question in. Cool, looks like we got another question in here. This person's asking, I'm working through self-placement challenge 22, and I keep getting an error. Error code attribution error module main has no attribute odds. Cool. So I will help you with this. The purpose of the self-placement challenge is to, you go up to the point where you get an error that you can't resolve, and if you're working on something that you can't resolve for more than we say like 30 to 40 minutes, then that's where you stop in the self-placement challenge, and then that way it'll tell you where in the material to start. I will help you with this, but this probably means that whatever part of our material that question challenge 22 corresponds with will help guide you to so that you know where to begin in our material. Specifically, we don't expect everybody to complete all of it. Also, if you can give me a link to that as well, that'd help me find it quicker. But let's just go through this. So the error is module main has no attribute odds. Okay. For both even and odds. Can anyone give me insight into why? I have done lots of searching online for this error message, but I still can't figure out why. Yeah, if you post a link to that, or here, I'll go try to find it. It might take me a minute to get to it, though. I think, is it in? Nope. See a self-placement challenge. Here it is. Okay. All right. Oh, there it is. Almost there. Okay, cool. So based on that code, I couldn't tell what was the problem, but since I have the problem statement now I know what the expectation is supposed to be. So this is kind of an important thing. And it's an easy thing to overlook, but a lot of people will ask me like similar things where they'll show me some code and like, hey, what's the problem with this? And it's not necessarily self-evident in the code, because I might run this and this just at a glance, this looks fine. I think this is going to be fine. So sum of 1000. Let's do this. Oops. So if I run this, name even is not defined. Okay. Okay. So this might be related to the error that you're getting. We have this list called evens and odds, whereas this is even and odd. So these are plural and these are singular. So we have to correct that. So if I do that, maybe that'll run. All right, that looks like a thing. Okay, so let me just look through here and just see what this is saying. So please write code that completes the following. Create a list called evens that will store even integers, and odds that will store odd integers. Then iterate through all the integers up to 1000, accumulating all the even numbers and evens and odd numbers and odds. Cool. So what this is asking for is just this part of the code. This isn't actually expecting a function at all, because it won't know. Okay, I see. Let's see. So let's see where it went wrong. Lists differ. So 2383 chars. This is 2383. Okay. And that's 0, 2, 6, 998. Ah, so this one includes 1000. So this code has to go actually through range 1001 in order for that to work. So let's go change that really quick, because that upper bound of the range won't include 1000. Okay, so this will work like this, and that's because the way our tests are written, since this question is asking that there's a list created in the global scope like this called evens and odds. If I do this in a function, I'll show you. If I do this in a function, how would I write a test to test if there's to test the value of evens or odd, right? If I say print, and I have to be able to access evens and odds outside this function, and I can't even do that in this document. If I say print evens, I'm going to get this evens is not defined down here. Yep, name evens is not defined. So these lists, your code did create those, and you basically had the right logic. The conditions were right, the appends were good, just needed to correct the names and then alter the range slightly. But if it's in a function, then these objects are hidden away forever. There's no way to get them out of that function. You can return their values, but you can't access them by those names unless you like unpack them or something. So, but yeah, you were really close. Good job, I would say. Oh, great. Great. Thanks for saying that. I'm glad that was helpful. Um, and then somebody's also saying, I just wanted to point this out. So in the original code that was sent, there was a space between the function name and the parentheses, and somebody's saying that shouldn't be there. By convention, that we don't do that by convention. It's actually fine if it's there though. It'll work. I could put a bunch of spaces in there. But by convention, we always put the parentheses after a function name. We put them immediately after the function, whether we're defining it or whether we're invoking it. So this is the definition and this is the invocation. And in either case, it's convention to put the parentheses immediately after with no space, but in either case, it actually works with a space. So kind of a, you know, it's good to point that out, but yeah, just kind of a sort of a secondary issue. Cool. And somebody's saying, just want to confirm that in this statement, it compares the elements in both nested lists successively. Both nested lists successive. Oh, sorry. I was thinking in the code that I wrote. I see what you mean. This is in the next statement. So I think this person is referring to this statement. Let me paste that in. I think probably everybody watching this is also on Slack, but just in case for somebody who might be watching this in the future, or who's not on Slack maybe. Okay. Let me read this again. Just wanted to confirm that in this statement, it compares the elements in both nested lists successively. And the moment it identifies the first element that's larger, it prints that nested list. It doesn't compare all elements within both nested lists unless the elements are equal. Oh, okay. So it sounds like your question is about like what's the behavior of max list of nested lists. So the behavior is dictated by whatever the first element is. And I apologize, I meant to mention that because I'm sure this is in reference to my first solution of the largest sub-sum problem, where I'm doing the max of this list of tuples. And this was my first solution that was wrong actually. because I sort of misinterpreted those examples, but it's a cool solution. So there's an odd behavior, and like I said, I apologize because I meant to mention this. There's an odd behavior when you're doing, this works with sorting or min and max. I think there's some others that it works with. I can't think of them at the moment, but I know sort or sorted, min and max, this will work with. So if I have a list of lists, and I sort them, and I'm gonna use sorted as an example because the same mechanism is at play here. So it'll show us, right? So if I do 2, 2, 3, 1, 2, 9, let's do a few more. Let's say 7, 0, 0, or let's say 4, 0, 0. Okay. Let's say 2, 0, 9. Okay. So what's going to happen here? Is it going to work? Yeah. What's going to happen here is it's going to go off of the first element in all cases, right? So if we look, the first lowest element is the, okay, how do I put this? The nested list with the lowest first element is this one. So this one's going to be first. And then the nested list with the next lowest, well, there's two, right? There's this one and there's this one. So what it does in that case is it goes and it compares the next element. So this one has the lowest, right? So this is the same kind of logic that you'd use to alphabetize something. Basically the same pattern, right? And then this one's the only one left, right? So even though this one has a really low sum, that'll work. So this behavior, you can expect this kind of behavior from a list of lists, a list of tuples, a tuple of tuples, or a tuple of lists. Just like any sort of collection like that that's nested, you can expect this sorting behavior to be consistent. And the same thing will be true with min and max. If I do max, I'm gonna get the max. I'm gonna get the element with the largest first index, which is 400. Does that make sense? I feel like I've explained this better before. I feel like I'm not explaining it super well at the moment. But yeah. Okay, I just thought of a better example. Let's do, if I had a list of tuples and I had, let's say, oh, that does make sense. Okay, cool. I'm gonna leave that one there unless somebody else wants me to dive into that again. Yeah, you're welcome. Cool. Yeah, that's an interesting behavior. Hopefully that answers your question. That gets at what you were looking at. Oh, I think that's what you were saying. I'm sorry. I just realized that is what you were saying. I believe that is what you were saying. Okay, cool. Lost audio. Check. Somebody's saying we lost audio. I see audio. OBS is telling me that I have an audio response here. Let's see. Let me just check on the stream really quick. Yeah, cool. Oops. We'll do that. Okay, cool. All right, we don't have any active questions at the moment. I think I'll just give you all another minute. If I don't see anything, maybe we'll do a couple Code Wars problems before we wrap up. Cool. Looks like we've got another question. Last question in this link. Magic methods. Oh, is this in? This looks like it's in further studies, I think. Let's go through this. A whole OOP challenge. Fill in the following methods in the class according to their doc strings. Do not change the name of the classes. Okay, cool. This is a little outside of the what I'll usually cover, but this is a cool topic. We're getting into a little bit of object-oriented programming, so I'll give context for anybody else who's watching who might not know what this is about. I think this is from our further studies section. Oops. Let's do this. This is going to be an advanced Python, I think. Type handling, generators, recursion. Okay. Where is, oh, it's in here. Further studies, not required for the TI. Okay. Yeah, so this is in our further studies section. So for anybody who's watching this, this is a fun topic. We're sort of getting into some of the details of object-oriented programming, which is not something not something that we teach in premium prep, but it is something, it's an important programming concept that you'll learn in the DSI and kind of after the DSI. And it has to do with building classes. So in this case, we have a class called linear polynomial, and a class is essentially a group of functions and properties, which are kind of like variables inside of a function. Classes have these special sort of built-in, when a function is inside of a class, we call it a method. So they have these special methods that play specific roles. You can define exactly what they do, but they will have specific things. So for this example, Dunder's string, these are called magic methods, the ones with double underscores. Double underscore on the beginning and the end. Sometimes they're also called dunders. I usually call them dunders. So dunder stir or dunder string, this is going to be, says returns a string representation of the linear polynomial. So when we cast this data type as a string, we have to have a schema for how to do that. Like how should linear polynomial be represented when it's being represented as a string? So that's what we're going to do here, basically. So it returns a string representation of linear polynomial instance referenced by self. Returns a string formatted like mx plus b, where m is self.m and b is self.b. Okay, so this is going to return a mx, excuse me, this is going to be, I'm going to do an f string here. I'm going to say self dot m x plus self dot b. Okay, and then add. So this function adds the other instance of linear polynomial to the instance referenced by self. The sum of this instance of linear polynomial with another instance of linear polynomial, so returns, okay, excuse me. So this sum will not change either instance referenced by self or the other. It returns, so this is good that it's clarifying this. If it changed either instance, then that would be a mutation. So it returns the sum as a new instance of linear polynomial, initiated with the newly calculated sum. Okay. So let's do, where does it describe how to do that? Let's see. Okay, I see. So add is going to essentially define the behavior of being able to add two polynomials together. So in order to do that, we can, oops, we are going to return a new instance of linear polynomial. So when I initialize this, every time this gets initialized, we set we take in two new values. I think it would probably be best if I just did a test for this. So, LP equals linear polynomial. I'll just call this LP1, linear polynomial, and we're going to take in M and B. So that's going to be, let's just do 10 and 7, I don't know. And let's print out, and I think LP1, I think I'll need to cast that as a string. Oh no. So since I defined that string definition, it is gonna show me that correct string. So that's good. If I didn't, by the way, I mean, if I didn't have this string definition here, I'm gonna get this, well, actually, I think I need to do this. So if I don't define the behavior for stir, see what happens when I print it out. Oops. When I print it out, I get this linear polynomial object and a RAM address or a location in memory or something like that. So in order to make it visible, to make it printable, having a stir, having the ability to describe what this is as a string is obviously helpful. Cool. So that'll give me that representation, and then I believe I should be able to do, let's do LP2, something like this. So if I do LP1 plus LP2, so add is going to define behavior for the plus, I believe it'll define behavior for the plus operator. So this is going to take in self, which is going to be LP1, and other, which is going to be LP2, which I'm going to define as 20 and I don't know, 14. How about that? Okay, so what we want to do is we want to return a new instance of linear polynomial. We don't want to alter either instance. And we want to initialize it. See how I'm initializing it down here with 10 and 7. I'm initializing it down here with 20 and 14. We want to return a new initialized instance with the sums from 1 and the sums from 2 as M and B respectively. So this is going to be self dot M plus self dot B. Oh, excuse me. I'm doing this wrong. Self dot M plus other dot M and self dot B plus other dot B. That should do it. So if I do that, so I get 30x plus 21, right? So if I do 10 plus 20, that's 30, 30x, plus 7 plus 14 is 21. So that I've just defined how to use the plus operator with this object. which is pretty cool. And let's actually submit this and make sure that my code is actually going to work. Of course, it doesn't really count if, oh no, I totally just closed Chrome. All right. Okay. There we go. Sorry about that. Ah. So let's do that there, and we'll do this one here. Cool. All right, that'll do it. Cool. And it looks like all right, it looks like we got another question. I want to give this one because I know this is a bit out of the scope of what I usually cover. So if anybody's got any questions about this, feel free to put them in there. I'm just gonna give us like 20 seconds on this. Okay, cool. Oh, great. Looks like that was helpful to you. So yeah, happy that was useful. All right, let's move on. I don't see any follow-ups with this one, so let's move on to the next one. This person's just saying, help with question 3. Tuples are immutable. Okay. And again, pretend like you didn't see that I had answers in there. Let's see if I can copy that out real quick. Bam. Okay. Okay. So let's look at this one. Write a function called tuple creating tuple. Okay. Oops. Done. All right, next question. No, I'm just kidding. Write a function called that. This function takes 3 arguments called name tup, age tup, job tup. The 3 tuples are parallel. Okay. I know what parallel is. So names ages, jobs, equals, and these are going to be tuples of, let's do James, Sally, Jessica, and oh, we don't need anybody else. Okay. Let's do 27 and 53 and 35. And let's do jobs. Let's say we've got James is a plumber. And Sally is a pilot. Pilot. P-I-L-O-T. Oh my gosh. And Jessica is a data scientist. Oops. Okay. Excuse me. So I'm going to pass names, ages, and jobs. There we go. And then now I should probably make these. There we go. Okay, so the three tuples are in parallel since they contain the same number of items. Each item at a given index corresponds to the other items at the same index, i.e. index 0 across all three tuples holds the name, age, and job of the first person. Index 1 holds the name, age, and job of the second person, etc. Right, so James is 27. I think it's probably obvious, right? But James is 27. They are a plumber. And then Sally is 53. She's a pilot. And Jessica is 35, and she's a data scientist. Okay. Good. So presumably we want to print out, not that I remember this function at all. Presumably we want to return, yeah, I'll just read this. This function should return a single tuple where all of the values in the given indices, this function should return a single tuple where all of the values at a given index are tuples of the data for that same person. Okay, so we're going to return run. We're going to return. There's a kind of a cool way to do this. I think that's going to do it. Oh no, of course not, because you need a colon there. Okay, so this, we've turned this, into this. So this is our output. And I'll show you how to do this without zip. The zip way is cool because is zip my favorite function? I don't know. I feel weird saying that I have a favorite function, but I really like zip. I don't know if you're supposed to like functions, but I like it. This is our output here. So James 27, they're a plumber. Sally's 53, they're a pilot. and it just goes 35, and they're a data scientist. So the cool thing about zip, anytime you have this, anytime you're dealing with information in parallel, zip is probably going to be useful to you. Another way of thinking about a parallel data problem, or another way that it tends to like come up that you intend to encounter it, is like you'll be working with something and you'll think like, oh, I need to iterate through this thing, but I also need to iterate through this other thing at the same time. And you'll think like, if there's only a way for me to iterate through multiple things simultaneously, the answer to that is always zip. So what we can do is we could have a list. Sorry, I just kind of changed gears there. Let me finish that thought before. Zip is a useful function. What this is doing is zipping these three iterables together. Now I can zip 2 things together. I can zip 18 things together. I can zip as many lists or tuples or strings together, and I can mix and match. If I wanted to zip a range and a list and a tuple and a string and another list, I could do that. I can zip as many things of different types, just so long as they're all iterable. If one of them is shorter than the others, or it's going to give me, it's going to return as many tuples as there are elements in the smallest object that I give it. But basically what it's doing is it's giving me back tuples of all of the elements at a given index across each of the lists. I use that term broadly, each of the arrays or lists or tuples, whatever I'm handing it. It's giving me each element at each index simultaneously grouped in tuples. So that's what it's doing. So another way of solving this without using the just doing the one-line return like that. And let me just, before I continue, I don't think I've submitted this. Let me just prove that this is going to work. Cool. Oops. Okay. I'm going to show you how to do this with zip and a for loop. It'll be a little more kind of standard accumulator style. We're going to start an empty list, and for now we're going to return it. Well, I was going to say we're going to return it as a list. I'm going to do a list just so we can accumulate or append into it. Makes accumulation a little easier. You can do a tuple accumulator, but I think it makes sense to just have a list and append to it in this case. But we're going to cast that list as a tuple because we wanted it to return a tuple. And then I'm going to say for name, age, job in zip. So this is usually the context that you'll see zip in as the iterable and a for loop. That's most often how I use it and how I've seen it. This is a very typical usage of zip. And then we can say list.append. And this will just be name, age, job. And the reason I'm doing name, then age, then job is I'm passing in that order name tup, age tup, and job tup. So I can do name, age, and job. I can unpack it in the same order that I passed in the list. So I can do that. Oops. Append takes exactly 1 argument. Of course, they gave it 3 right there. I meant to give it a tuple. So I just put some parentheses around that. That way it's 1 tuple of 3 elements that I'm appending. And now I have the same thing. So this should work as well. Cool. And then finally, let's say if you don't know zip and you want to do this with range, and of course if you're if you're watching this, you now know zip, but a probably more ubiquitous or more like a tool that we teach before zip that has like kind of a wider use case. Let's say later on you forget that you forget what's that function called, zipper or zoop or Zoopatiscana or something. You can use range, and you can do for I in range len, and you can just do len of range len, and this will give you the indices. And you can just do the length of any of these. It doesn't matter which one I choose. So range len, name tup, age tup, job tup, doesn't matter. And then what we'll do here is we'll append the tuples sub I. Whew, okay, there we go. So we'll do append a tuple of name tup sub I, age tup sub I, and job tup sub I. And you get the same result. And let's just submit this and make sure that's also, or just prove that that's also going to work. Cool. So I like that one-liner solution. And I think this is exactly the code that I had before. Let's just check out what I had before. Yeah, that's exactly the same. Cool. All right. Hopefully that was helpful. We're right about at our normal stopping point, so I'm going to wrap up here. I'm going to send in my code into the Slack thread. You know what, I should put it in the, well, we'll see if I can do that. Let me just see about this really quick. Yeah. Cool, so that code's in the Slack thread if you want to reference it, let's take a look at it. So yeah, thanks for everybody who brought in a question today. I know a couple of people had multiple questions, which is great. That's like the primary purpose of study hall, and I'm happy to see people engaging in that. Do feel free to reach out if you want to do a one-on-one, if you want any mentoring. I'm available. I have a lot of availability this upcoming week for meetings. And yeah, don't be a stranger. Don't feel shy. I'm happy to meet with folks. This Monday, I'm going to be hosting. We're probably just going to forego study hall on Wednesday. A lot of people are sort of out of town, out on vacation. Tovio will be out of town. And I'm probably just going to take a little downtime myself and just kind of try to catch up on some other work projects and maybe even go outside. So yeah, well, it was fun, and I will see you in the future. You'll have a good rest of your evening. All right, bye-bye.